Today on the Y of Math, we're going to be covering annuity payments and the value of an annuity. Now we'll start with the inverse exponential infinite sum. Sum from 1 to infinity of 1 over z to the I power. That's 1 over z plus 1 over z squared plus 1 over z cubed, and so on out to infinity. Now if we set that equal to y, we can multiply through by z. And as you can see here, each of the terms goes to the previous term in the infinite sum, except for the first term, which becomes 1. So z times y equals 1 plus y. You can bring all the y's onto one side, factor out y, and that gives y times z minus 1 equals 1. So y equals 1 over z minus 1. Now the way that this applies to annuity payments is the present value of an annuity, or of a payment made n periods into the future, is equal to 1 over the 1 plus r to the n power, where r is the period interest rate and n is the number of periods. And you multiply this factor by the amount of the payment in order to calculate its present value in dollars. So, a perpetual income stream of a fixed amount would have a present value of 1 over 1 plus r plus 1 over 1 plus r squared plus 1 over 1 plus r cubed, and so on, which goes to 1 over r, which makes sense. Whatever interest rate we have for the present value of the annuity, the interest only would be the size of the payment, and it will be worth the same a year from now or a month from now, whichever is your compounding period. Now, an annuity that has a finite duration would simply be the value of the perpetuity minus the value of an annuity beginning at the end of the annuity term. So that gives us a present value interest factor for annuities equal to 1 over r times 1 minus 1 over 1 plus r to the n power. And to compute a payment for an installment loan, you would take the amount of the loan and divide it by the present value interest factor for annuities. That's all for today. Remember to like, share, and subscribe, and leave any questions in the comments section.